So in this short video we will discuss about the second order systems. So the transfer function for a second order system looks somewhat like this: ys by xs, this is equal to kp by tau square s square plus 2 zeta tau s plus 1. This is the general representation of a second order system transfer function. So I will explain each of these terms one by one. Kp is the gain. What is tau? Tau is nothing but the time constant. So one more thing is, what is this zeta? Zeta is nothing but the damping coefficient. This is the damping coefficient. So if I take this entire term and if I equate it to 0, what I will get is the characteristic equation. So tau square s square plus 2 zeta tau s plus 1, this equal to 0. This is the characteristic equation. So now what we will do is we will try to find the roots of this equation. So if I solve this, what I will get is s equal to, I consider this as a quadratic equation. I can take this as a quadratic equation and I will solve for the roots of s. So s equal to, if I write it over here, it is given by minus b plus minus root over b square minus 4ac divided by 2a. This is how we solve. So we will apply this same thing for this equation. So if I do this, what I get is b over here is 2 zeta tau. So it will be minus 2 zeta tau plus minus root of b square. What is b square? 4 zeta square tau square minus 4 into ac. What is a? A in this case is tau square, so tau square. And what is c? C in this case is 1, so this will be 1 over here divided by 2a. So 2a is 2 tau square. So this is what we have. So now what we do is we can simplify this. So s equals minus 2 zeta tau. So if I separate this denominator into two different parts, I will get divided by 2 tau square over here, and on other side plus minus root over 4 zeta square tau square minus 4 tau square divided by 2 tau square. So this is what I have. If I further simplify this 2 will get cancelled, and what I have is minus zeta divided by tau. This is over here, and plus minus over here, what I will get is, if I simplify inside the root, I can write this as 4 tau square. So this becomes zeta square minus 1 divided by 2 tau square. So you can see that over here what I will get is this 4 tau square will get out of the root. So minus zeta by tau plus minus, so 2 tau root zeta square minus 1 divided by 2 tau square. So 2 will get cancelled. What I will have is minus zeta by tau plus minus 1 by tau root zeta square minus 1. So this is what I get as the roots of the characteristic equation for the second order system. These are the generalized roots for the characteristic equation, that is this one for second order system. So now depending on the value of this zeta, we will have different nature of the root. So we will categorize them in a table. So on the first column I will write this zeta over here. So what is this zeta? Remember, I have said that zeta is the damping coefficient. On the second column we will have the nature of roots, and on the third column we will have the type of response. So first, when zeta is less than 1, when the value of zeta is less than 1, what we will obtain? The roots will be obviously complex, because if you put less than 1 over here, you can see that inside the root we will have a negative number. So this will give a complex number, hence the nature of root will be complex. If zeta is less than 1, we will have complex roots. So for complex roots, the type of response will be oscillatory or underdamped. So next, when zeta equals to 1, when the damping coefficient equals to 1, the nature of the root is real and equal. You can see that if I put zeta equals to 1 over here, I will end up getting s equals to minus 1 by tau. That is 2 equal roots I will get, because this entire term will be 0 if I put zeta equals 1. So the nature of root is real and equal. What is the type of response? For zeta equals to 1, that is the damping coefficient equal to 1, the type of response will be critically damped. So at last what we have is when zeta is greater than 1. When zeta is greater than 1, the nature of the root will be real and unequal. And what is the type of response? The type of response is overdamped or non-oscillatory. So now what does these responses mean? That is underdamped, oscillatory, critically damped, overdamped, non-oscillatory. What does this means? So to understand all this, we will see this graph. In this graph, this is the response curve for the second order systems. You can see that for critically damped, this is the curve for critically damped. This is the curve for critically damped. That is when zeta equals to 1. That is this case. When zeta equal to 1, we get real and equal roots, and the graph will look somewhat like this. It is critically damped. Next is when zeta is less than 1, that is complex roots. So for complex roots, the type of response is underdamped oscillatory. Here you can see when zeta is less than 1, that is 0.1 value of zeta, the response is oscillatory, that is underdamped. You can see that the one I am tracing with the red color, this is oscillatory behavior. It occurs when underdamped response, that is zeta less than 1. Lastly, for zeta greater than 1, that is real and unequal roots, we have overdamped or non-oscillatory behavior, which is this curve. This curve is overdamped or non-oscillatory behavior. You can see that it occurs when zeta equals to 2, that is zeta greater than 1. So all the three responses I have explained with the help of this diagram. Next, what we will do is YouTube manometer. This is an example of a underdamped second order system. This is asked in lot of exams, that give an example for a underdamped second order system. So YouTube manometer is an example of an underdamped second order system. So now what we will do is we will study the second order output curve in a more detailed manner. So we will understand each of these terms, what is overshoot, decay ratio, period of oscillation, everything. So first we will see what is this overshoot. So overshoot is the measure of how much the response exceeds the ultimate value following a step change, and it is expressed by the ratio A by B. Here in the figure you can see that this is A and this is B. If I take the ratio of this A by B, what I get is the overshoot. Another way of dealing with this is overshoot. You can write directly overshoot equals e power minus pi zeta divided by root 1 minus zeta square. This is the direct way of calculating overshoot. If I know the decay ratio, that is zeta, if I know the decay ratio zeta, then I can easily calculate the overshoot using this expression, that is overshoot equals e power minus pi zeta divided by root 1 minus zeta square. So this is equal to A by B, that is this ratio A by B. Next what we will study is, so decay ratio is the ratio of the sizes of successive peaks, that is it is given by C by A. So what is C? If you look closely in the graph, you can see that this is C. This distance, that is this one is C, this length is C, and what is A? A is this. So the ratio of C by A is nothing but the decay ratio. So decay ratio is the ratio of the sizes of successive peaks. In the graph you can see that the first peak is this one and the next peak is this one. So the size of C by A, this is defined as the decay ratio. So expression wise it can be calculated by decay ratio equals to overshoot whole square. Decay ratio equals to overshoot whole square, that is it is equal to e power minus 2 pi zeta divided by root 1 minus zeta square. So this is how we can calculate the decay ratio. Next what we have is, so rise time is the time required for the response to first reach its ultimate value. Again in the graph you can see over here, this is the rise time, that is the time required for the response to first reach the ultimate value. This is the ultimate value. So when it reaches the ultimate value for the first time, the time that we have is known as the rise time. I hope it is clear now. Next what we will study is response time. Response time is the time required for the response to come within plus minus 5% of its ultimate value and remain there. So again if you see the curve, so I have cleaned the diagram so you can understand better. Now what is response time? You can see that response time is the time when the response reaches plus minus 5% of the ultimate value. This is the ultimate value, this is the ultimate value. Plus minus 5% would be somewhat like this. This is plus 5% or minus 5%. So the time required to reach within plus minus 5% of the ultimate value is known as the response time. You can see it from the diagram again. Next we will study, so now we will study two important things. First is the frequency omega. So this is the angular frequency, this is given by root 1 minus zeta square divided by tau. This is how we can calculate. Zeta is the damping coefficient. So if you want to find the corresponding linear frequency, we know omega equals to 2 pi times nu. This is the linear frequency. So we can easily convert from this to the linear frequency, and if nu is given, we can also convert to omega likewise. So if I know omega, I can change between omega to nu or nu to omega. This is easy. Next is the natural frequency. So natural frequency is different from this frequency. This natural frequency is if zeta equals to 0. If zeta equals to 0, then the frequency is called the natural frequency. It is denoted by omega n. It is equal to 1 by tau. It is equal to 1 by tau. So this is again the angular frequency, angular natural frequency. If they ask to calculate the linear frequency, then again I can use omega equals to 2 pi nu. Here in this case it will be n because I am talking about natural frequency. So I hope this is clear what is this frequency and the natural frequency. Now what we will do is we will try to solve a problem on this. Then it will be more clear. So the question says a step change of magnitude 10 is introduced into a second order system and the transfer function is given. This is the transfer function that they have given. Now they are asking to calculate the percentage overshoot, decay ratio, ultimate value, maximum value, frequency and natural frequency of the response. So what we will do is we will first see what is the general form for a second order system, that is the transfer function. So transfer function for a second order system can be written in this way: kp by tau square s square plus 2 zeta tau s plus 1. This is the general form, and I can write for a second order system, I can write the transfer function in this way. Now we will compare this transfer function with this. So what they have given in the question is 10 divided by 2s square plus 0.3s plus 0.5. This is what they have given, 2s square plus 0.3s plus 0.5. This is what is in the denominator. Now we cannot compare these two. Why? Because here I have a 1 and here I have a 0.5. So what I will do is, instead of writing it this way, I will take 0.5 common. Then this will become 10 divided by 0.5 times 2s square divided by 0.5 plus 0.3s divided by 0.5 plus 1. So now if I further simplify this, this becomes 20 divided by 4s square plus 0.6s plus 1. So this is the simplified form of this one. So now I can compare this with this, that is kp by tau square s square plus 2 zeta tau s plus 1. So let me write them side by side: kp by tau square s square plus 2 zeta tau s plus 1. Now by comparing both of these, I find that tau square equals to 4. So what is tau? Tau equals to plus minus 2, but because tau is time constant, hence it will obviously be plus 2. So tau is 2. This is what we obtain. Now if I compare this term and this term, what do I get? 0.6 equals 2 zeta tau. Now tau is already 2, so what will be zeta? Zeta equals to 0.6 divided by 2 into 2. This is what zeta will be. So zeta is the damping coefficient, and in this case the value of the damping coefficient is 0.15. This is the value of zeta. So I know zeta, I know tau. Now we can easily calculate all of these. So first we have to find the percentage overshoot. What is overshoot? So from this diagram you can see that overshoot equals to A by B. The value of A by B is the overshoot. So what is A by B? A by B equals to e power minus pi zeta divided by root 1 minus zeta square. So I know that value of zeta is, what is zeta? We have just calculated zeta as 0.15. So 0.15 is zeta. So if I put in the values, this will simply be e power minus pi into zeta divided by root 1 minus zeta square. So if you simply put this in a calculator, the value of overshoot, that is A by B, that you will find is 0.621. This is the value of the overshoot. So in percentage this is equal to 62.1%. so overshoot equals to 62.1%. next what they are asking is decay ratio. So decay ratio is very simple, it is simply square of overshoot. What is decay ratio? decay ratio equals to, so from the figure the decay ratio is this C divided by A. So C by A is decay ratio, C by A. So it is further written as overshoot whole square. So if I do overshoot whole square, that is 0.621 whole square, what I will get is 0.385. This is the value of the decay ratio. So we have found two values, that is overshoot and decay ratio. Now they are asking what is the ultimate value of the response. So to calculate the ultimate value, that is this value, to calculate this value, what we have to do is, this is just a random figure, this figure is just for understanding. So if I need to find the ultimate value, what I need to do is I need to use the final value theorem. What does the final value theorem says? In time domain, if I want to find yt at limit t tends to infinity, this will be equal to limit s tends to 0 s times ys. So this is in s domain, this is in time domain. If I want at t tends to infinity, what is yt? This is equals to limit s tends to 0 s ys. So what is ys? Ys by xs, I know ys by xs. Ys by xs is nothing but this transfer function that they have given in the question, 10 divided by 2s square plus 0.3s plus 0.5. So I can either write this or I can write the simplified version, which is this one. I have simplified this. So if I write this, it becomes 20 divided by 4s square plus 0.6s plus 1. This is what we have, ys by xs. This is the same thing as writing this. Okay, so now what is this xs? So if you read the question carefully, you can easily find what xs is. xs is nothing but 10 by s, because they have said that step change of magnitude 10 is introduced. That means what is xs? Xs is nothing but 10 by s, because if I take the Laplace of 10, the Laplace transform of 10 is 10 by s. So that is what xs is. So if I put it, what I will get is ys equals to 20 divided by 4s square plus 0.6s plus 1 times 10 divided by s. So this is what ys is. Now if I put this limit, what I will get is limit s tends to 0 s ys. What will this be? This will be equal to s into this entire thing. So 20 into 10 divided by s into 4s square plus 0.6s plus 1. This is what I will get. This ss will get cancelled. So what I will have is 200 divided by something, but see s tends to 0. So if I put s0, this will cancel out, this will cancel out, I will simply get 200. So this is nothing but my ultimate value, that is this value. This value will be 200 for this problem. This value will be 200. Now what we need to find is, they have asked what is the maximum value of the response. Ultimate value we have calculated, it is 200. So to calculate the maximum response, that is this entire part 200 plus a, this is the maximum value. So in order to calculate the maximum value, I need to get the value of a. So I know the maximum value, I also know the overshoot, which is a by b. I have just calculated the value of the overshoot, which is a by b. A by b came out to be 0.621. So this a by b equals to 0.621. Now if I know the value of b, I can calculate this. So what is b? If you see in this figure, b is nothing but the ultimate value. B is nothing but the ultimate value. So b equals to 200. B equals to 200. Overshoot I know, I can easily calculate a. A equals to 0.621 into b, which is 200. So if I do this, the value of a that I will get is 124.174. This is what I will get, the value of a. So now I know the value of a. I know the value of a, and I also know the b, which is the ultimate value. So a plus b will give me the maximum value. A plus b will give me the maximum value. So simply if I do a plus b, what will I get? 124.17 plus what is b? B is the ultimate value, which is 200. So this plus 200, this will give me my maximum value, that is 324.174. This is what we will obtain. So here it will be 124.174 because I have written 124.174 over here. So this is the maximum value, 324.17. so I have calculated the maximum value also, I have calculated the ultimate value also. Now what is the frequency of the response? Frequency, we will calculate the angular frequency. Both for frequency and natural frequency we will calculate the angular ones, that is omega and omega n. So what is omega? I have explained above what is omega. Omega equals to root 1 minus zeta square divided by tau. So root 1 minus, what is the value of zeta? The value of zeta we have calculated as, 0.15. So 1 minus 0.15 whole square root divided by tau. What is tau? Tau is 2. We have calculated the value of tau also. So we have calculated the value of tau, it was 2. Hence what will this be? Root 1 minus 0.15 whole square divided by 2. So what will this be equal to? If you do this, if you do the calculation, you will get this as 0.494. This will be the value of omega. And what will be the units? Unit of omega is radians per second. This is for angular frequency. Now what we need to calculate last is, at last we need to calculate the natural frequency. So omega n equals to, this is very simple, omega n, which is the natural frequency, this is simply equals to 1 by tau, because for natural frequency we need to put zeta equals to 0. So if I put zeta equals to 0 here, I get 1 by tau. So tau is 2, so 1 by 2, it is simply 0.5 radians per second. This is the value of the natural frequency. So see, we have calculated all the things that they have asked. So this is all about this video. What we had done is, we had seen the second order system transfer function, we had seen the roots of the second order system characteristic equation, and also we have solved a problem. Thank you.